It is stunning news that the James Webb Space Telescope has found proof that the universe has quit growing. The space industry is at an emotional turning point. Does this imply that the universe will soon come to a total stop and that we are approaching a major tear or large freeze, wherein the whole universe might either be destroyed or unexpectedly freeze? Researchers around the world are concerned and examining the ramifications of these latest revelations for our current cosmological models. We must now ask ourselves crucial inquiries about the nature of space and time. The possibility of the development of the universe will soon be celebrating its 100th birthday. During the 1920s in the USA, an astronomer named Edwin Hubble was exploring the then newly discovered galaxies. It was at that time that researchers first realized our Milky Way was not the entirety of the universe, but merely one galaxy among many. First, the Andromeda cloud appeared, followed by an increasing number of galaxies opening up before Hubble's eyes. He was perhaps one of the earliest individuals on this planet to comprehend just how vast the universe truly is. Hubble was not only confronted with this revelation but also noticed something that astonished him even more: the galaxies far away from us seemed to be moving away. How could this be explained? Hubble estimated the movements and distances of the galaxies using the redshift of light. The further away the light source is, the more the spectrum of the light is shifted to the red. Hubble observed galaxies, their directions of movement, and assessed their speeds. In doing so, he identified a linear relationship that later became known as the Hubble constant. This states that distant galaxies are receding from us in proportion to their distance. Hubble published his pivotal discovery in 1929 and later combined his findings with the theory of a Belgian priest and physicist, Georges Lemaitre, who had been investigating the newly found galaxies around the same time as Hubble. Lemaitre proposed in 1927 that the universe was expanding from a primordial state of high density and temperature. This concept later became known as the Big Bang theory. Lemaitre's work was largely based on the field equations of Albert Einstein's general theory of relativity, which predicted that the universe could be dynamic and would either expand or contract. Along with Hubble's discovery, Lemaitre's thought and Einstein's equations of relativity became the foundations of our cosmology. Little has changed in these foundations for nearly 100 years until the James Webb Space Telescope entered the scientific arena. This revolutionary new telescope is now revealing a series of phenomena that are inconsistent with the current theories of standard cosmology. While it is now common knowledge that physics is facing a significant crisis due to Webb's discoveries, it is less well known that these issues and challenges are not new. In fact, scientists have long found that the universe does not behave quite as predicted by measurements, and they have even discovered that, for some puzzling reason, it has stopped expanding to the extent that our old ideas of physics can explain. Is our universe a whirlpool? It is an intriguing time filled with news, noise, and discussion among perplexed researchers. One of the most critical issues in assessing the current state of our universe is the question of dark matter and dark energy. Observations of the rotation curves of galaxies and the cosmic microwave background radiation have shown that the visible matter in the universe is not sufficient to explain the observed gravitational effects. This led to the hypothesis of dark matter, an invisible substance that comprises about 27% of the total matter-energy density of the universe. But what if our estimates of the constituents of our universe were completely incorrect? Webb's discoveries provide evidence that we have, up until now, fundamentally misinterpreted essential aspects of the universe. This might begin with the rotation of galaxies and certainly does not end with the expansion of the universe. Where these phenomena do not appear, the existence of dark matter and energy may not be necessary either. Another significant issue arose in the late 1990s when scientists found that the expansion of the universe is accelerating. This revelation supported the theory of dark energy, which seemingly drives this expansion and could be responsible for changes within the constants. Once again, we might have made a colossal error if our previous measurement techniques were flawed or based on entirely misleading assumptions. There may be neither a linear expansion nor a realm where the universe is growing as Hubble and Lemaitre suggested. In fact, some calculations indicate that our universe could be much more like a giant whirlpool fed by various sources. Imagine how energy and building blocks of matter are funneled into this space through different sources. In some areas, this would lead to more turbulence, while in others, the dynamics would be smoother, much like a whirlpool whose planes are widely spaced. The notion of the expansion of the universe would then cease to exist. Rather, scientists would need to admit that their conclusions rely on observational errors. This model of the universe is not currently accepted, as additional key evidence is lacking. However, recent observations from the James Webb Space Telescope are pushing these assumptions forward, and gradually researchers are confronting uncomfortable insights. Are we nearing the big tear, the big crunch, or the big freeze? It sounds unnerving because scientists have established that an expanding universe would ultimately have to end in a catastrophic scenario at some point. Imagine the universe continues to expand and expands until it becomes fragile and ultimately breaks. Here we arrive at the prospect of the big tear, a speculative idea where the expansion of the universe will lead to devastation. Sadly, the big crunch is not a much more hopeful scenario either, as the universe will ultimately implode when it is depleted. If we follow this theory, the expansion would stop at a specific point, reverse, and all the wonders of the universe would collapse. Let us also consider the big freeze, wherein the universe exhausts all its energy over time and is frozen in a sort of eternal stillness. Shock state. In this multitude of cases, the extension stops suddenly, and there is a sort of breakdown or shock. It's truly startling on the grounds that specialists have found districts in the universe that highlight an upcoming finish to the development. Are we very nearly the breakdown of the universe? The most recent information proposes that the construction of the early universe was substantially more complicated than recently thought and that there might be obscure actual cycles impacting nearby development rates. This could prompt key changes in our comprehension of cosmological standards. The concepts of dark energy and dark matter might have to be totally modified, and ideas such as a universe that is everlasting and fed by many sources are picking up speed once more. The possibility of everlasting expansion comes from the work of physicist Alan Guth, who proposed the first hypothesis of infinite expansion in the mid-1980s. This hypothesis was subsequently expanded further by Andrei Linde, who presented the idea of timeless expansion. The inestimable expansion hypothesis states that the universe went through a period of remarkable, fast development in the absolute first minutes after the Big Bang. Linde expanded this hypothesis by showing that in an inflationary universe, certain areas can keep on developing dramatically while other regions stop their expansion and go through ordinary development. This leads to the thought of a multiverse, where new bubble universes are continually being created, each of which might have its own actual properties. In Linde's model of everlasting expansion, there is no distinct start or end to the universe. Rather, the interaction of bubble development continues endlessly, demonstrating an interminably existing multiverse. Has the universe truly come to a stop? Now, it might sound peculiar, but it's true, our universe has, in a way, come to a halt. The development, as far as we might be concerned, or as we thought we knew it, has certainly come to a temporary stop. All elements in the universe are at a stop right now since they were just concepts in our brains or hypotheses on paper. We are now experiencing a huge freeze, a shock wave that has brought our science to a stop and deadened it. Webb's pictures and estimation results are putting the space industry and science in a condition of vulnerability. All pictures that show the youthful universe or that refer to enormous scale structures denounce the old ideas. The progression of new discoveries does not stop. The Webb continues to provide yet another image. New estimation data that no longer fits the total picture of the universe, as researchers have drawn it for nearly a century, is currently imploding as imagined by the possibility of the Big Crunch. Today, like never before, the inquiry emerges with respect to whether this large number of speculations are simply off base and whether we might be living in a universe that is undeniably more unique and variable than we naturally thought. For a long time, analysts have constructed a place of cards and built speculations on flimsy establishments. Nearly our whole cosmology depends on dark matter and dark energy, which may ultimately never be demonstrated. Elective methodologies, for example, tired light, the Mond hypothesis, the hypothesis of holographic gravity, or the hypothesis of the variable speed of light, demonstrate the way that the universe can likewise be made sense of based on totally unique boundaries. Tired light goes back to the Swiss physicist Fritz Zwicky in the 1920s. He proposed that the light from far-off systems loses energy over huge distances and consequently shows up redshifted. This hypothesis was an elective clarification for the development of the universe, practically the same as the hypothesis of the variable speed of light, which states that the physical properties of light might have been various billions of years ago than they are today. If this is valid, our whole astronomical perspective isn't fundamentally wrong. The modified Newtonian dynamics propose that gravity is definitely not a steady amount either, but has been dependent upon shifts over the course of time. Holographic gravity is much more energizing because Eric Verland's thought suggests that gravity isn't a basic force but results from the essential principles of quantum information and thermodynamics. In plain language, this would imply that our universe functions like a giant multidimensional image in which we ourselves are potentially the co-creators of the actual amounts that we would be able to notice. If we combine quantum mechanics with the material universe, it could even be that we most definitely create the problems that our inherent science is currently facing. Become a supporter now and be part of every single new video.